All right, so we have a video here on interior intersections. Now, if you look at these two lines here in this circle in this example, notice that these two lines, I'm going to look at this line here first, hits the circle twice, but also continues to pass through it. Now, there's a lot of vocab with a circle, so I'm not going to make you memorize some stuff, or all the different types of lines and angles. But if you want to know, this is called a secant. Okay, it's a chord. So a chord would end on the circle and not pass through it. A secant just passes through it. It's a line, and a chord would be a segment because it has endpoints. So that's all. That's what it's called. I just wanted you guys to know that. You don't have to have that memorized. The circle vocab of a circle is just a whole lot. So in these interior intersections, you have your angles on the inside, and you need to know that they're not central angles. Okay, this is not in the center. So we're going to focus on angle 1. Angle 1, I call a left-right angle in this picture, or a west-east angle in this picture, meaning it's associated with the right and left arcs. Okay, so it goes with the arcs on the left and the right because it's a left or right angle in the center. So to find angle 1, you would take those arcs that I just highlighted in blue. So it'd be AD, arc AD, and arc BC, and you would just add them and divide by 2. That's for angle 1. And if you have a good grasp of what you're doing, you know what I'm probably going to do with angle 2. That is what I call like an up and down angle or a north-south angle. It works with the north and south arcs. So angle 2 goes with arc AB, which is the north arc up here, and the south arc. You add those together and you divide it by 2. That's how you take the average of something, is add them up and divide by how many there are. So moving on to the 6 examples. AED is an angle. Okay, that's an angle marking. Here's your angle in here. That goes with 45 and 109. So the first one, not too tricky at all. You just add those 2 arcs, divide by 2, and that would get you angle AED. And it also would get you this angle. Those are vertical and equal. Okay, so while we're on it, let's go ahead and find that. 45 plus 109 equals 154 divided by 2. That's going to be 77. So what I want you to know is all that stuff from Geometry 1 or Geometry A is here. Those are vertical, and these are half circles still. You still have that relationship in the middle. So this would be 77, 77, and this would be 103 to make it 180, a half circle. So that still exists in the center. So on number 2, angle STR. STR is I call that a north-south angle, and it looks like you have both the north and south arcs, so you would just add those up and divide by 2. All right, moving on to 3, YWX. YWX. So it looks like we can't find that angle with the 2 arcs provided. But if we go focus back on what I talked about on the one above it, you can find the supplementary pair to it. So if you find that red angle, and that goes with this arc 81 and 43, you can do a half circle to get that angle. So what you would do would take the 43 plus 81 divided by 2, 43 plus 81 is 124 divided by 2 is 62. That is not your angle. That is this red angle right beside it. So if you wanted to find the angle we need, you would just do 180 minus that to get the angle you need. And that angle is 118. All right, so here on number 4, the first time we're going to need to find an arc. Okay, so there's the arc. That angle goes with it, 62. So what we'll do is we'll say the angle. I'm going to call this arc X because that's just what we use for anything missing nowadays is only X. 62 is going to equal those two arcs divided by 2. So that is how you would find an arc. So you just multiply that 2 to both sides. Oops, 124. And this is what your equation would look like. Subtract 72 and you're done. Okay, CDE, one more time to find another arc. So we're looking for this. I'll call it X. We have the angle in other arc. So the angle in the middle is 128 equals X plus 73 divided by 2. And yeah, that's going to be a big arc. 128 times 2. And then we subtract 73. So you should get this arc is just over a half circle, 183. All right, QT. So it looks like we have QT. I do not have the angle. That red angle I just put a dot in is what we need. But you can find that. Just take 180 minus 79, and it's 101. Now you can set up the equation. Call this X. Now it's 101 equals the arcs. The two arcs are X and 95 over 2. All right, so while we're on while we're on this page, I might as well hit these 3 examples down here. This is the weird picture of this. It just looks different than all the other ones. Let's take a look at angle 1 and angle 2. First of all, you need to know the relationship of angle 1 and 2, that those two always add up to 180. Okay, so an intersection on the circle there, those two angles add up to 180. And angle 1, if you take a look at angle 1, it only has one arc inside that angle. And we're not used to seeing the arc actually go into the angle. We're used to seeing something like that, the arc on the edge of the inline or endpoints of the angle. So it's a little weird, but I treat these as inscribed. So angle 1 has one arc that's inside that angle. And angle 1 is half of that. So it is half of arc AB. Or arc AB just divided by 2. Angle 2 has this major arc inside it. So it would be half of that arc inside it. I'll call it BCA. So there's the math. So it's not too bad. It's just different looking than all the other things we've looked at. So we need to find angle DEG. So we're looking for angle DEG. There is one arc inside that, and its arc is 308. The math is just 308 divided by 2. Easy math, just weird looking picture. How to find angle DBC. Okay. 2 ways you could do this. You do know the circle is 360, so if we took 360 minus the 192, this is one way to get it. So that angle, that arc, that is inside that angle is 168. Then I would cut it in half and that would be my angle of 84. All right, so now we're going to find arc XY, and that's this little one in here. Okay, so I can find this big one that's associated with angle 151. 151 times 2 is 302. So this longer arc here is 302. And that blue arc makes the whole circle. So the math to get that little blue arc is this 316 minus 302. And you'd have it. Your blue arc in there, that little blue arc in there is 58. All right, so that video is over.